All right, we're going to talk about special solutions. So let's solve these equations and see what's so special about some of them. All right, so these are multi-step equations. So we're going to go ahead and start by simplifying each side of the equation. This is already in simplest form. Over here, it looks like we've got the distributive property. I'm going to distribute the -7 to both of those numbers. So I'm going to rewrite this, but I'm going to write it in standard form, which means the variable would come first. So I'm just going to use what property to do this? Do you remember? That's the associative property. I'm sorry, not associative property, my bad. Commutative property. Remember the CO in commutative property says change order, so the numbers are changing orders. Remember the sign had to go along with both of the numbers, okay? And on this side, we're going to drop down the 2 and distribute that -7. So we have -7y minus 42. Not quite done simplifying this side because I see that I have two like terms here. Neither of them have a variable. So we're going to write -7y minus 38 equals, and I'm going to put my variable first, so -7y, and then I have more negatives than positives, and that would be 40 more negatives. Now I want you to look at this stage right here. I want you to notice something, so take a look, pause the video, just look at it for a moment. We have almost, but not quite, the same problem on both sides. I have a -7y and a -7y. But after I multiply -7 by the y, I'm going to take 38 away. On this side, I'm going to take 40 away. So let's think about y. What would y have to be to make this a true statement, to make it work, the equation work? Well, nothing is going to work because -7 times y, whatever we make y, is going to be the same on both sides. And what number do you know of that you can take 38 away one time and 40 away another time and get the same answer? It will never happen. So let's keep going. Sometimes you'll recognize it here and you can write down the final answer, which I'll tell you what that is in a moment. Sometimes you're not going to recognize that because you didn't flip it and so it didn't look right, or you just weren't looking for it. There's so many other things to think of. So we'll still go on to the next step of getting all of our equations, our variables, to one side. So I'm going to go ahead and add a 7y to both sides. And that means this will be 0. We don't have any y's left, which will only leave us a -38. And on this side, they also cancel out, leaving us a -40. So it says -38 equals -40. This is what we call, and you can take notes over here, this is what we call a false statement. Right? It can't work. It's not true. Whenever you see a false statement, what it means is no matter what we plug in for the variable, it will never work out. And therefore, the answer to this problem will be no solution. So this is what you must write as your final answer, because you're the mathematician and you have to solve the problem, not let somebody else solve it. So when you see this, you don't box it, you write no solution. And you put a box around that because that tells us what y can be. It can't be anything. All right, number 2. I see the distributive property. I saw those parentheses. My eyes went right to it. All right, so 2 times 3 is 6b plus 4 equals, and over here we don't have to simplify. Looking at both sides, simplifying is done. That's step 1. Step 2, put all the variables on one side of the equation. When I say all the variables, what I mean is the one we're solving for. So I'm going to go ahead and move this one. So negative 5b, negative 5b. And even though we have a variable, that's still the addition subtraction property of equality. So I have one extra positive. So we have b plus 4 equals 1. Now we want b to be alone. That's our third step. We'll have that simple 1-2 step. Sometimes it'll actually be 3 steps. Could be more. I'm going to subtract a 4 from both sides, and we have b equals negative 3. So what makes that so special? We've seen a lot like that. But what we didn't realize is that's one solution. These are linear equations. So in this case, we have one solution. In this case, we have no solutions. So far we've got 2 different things that could happen. This one very specifically says the only number that will work to make both sides equal is a negative 3. Any other number, it won't work out, okay? All right, so let's take a look at this. Hopefully you see it already. Do you see the distributive property? We have parentheses, so we're going to distribute that negative 3 out. All right, so we have negative 3x minus 15 plus 2x equals negative 15 minus x. All right, doesn't look like we're done. On this side, we still need to combine some like terms. Remember, showing your work is not for you. It's for the person who's looking at your paper so that they can follow your logic. Okay, so don't skip showing the work. For me, your teacher, following your logic is the most important step. I need to understand that. I need to understand your steps. Perhaps we're not going to solve it the same way, okay? So I want to see the logic behind what you're doing. So we have a negative 3 and a 2, so that will leave us with a negative 1. I'm not going to write the 1. I'll just have it implied. Minus 15 equals, and on this side I notice that they're not in standard form, so I'm going to use the commutative property again, and I'm going to switch the order. I'm going to put the negative x first and the negative 15 second. So negative x minus negative 15. And so right here, I want you to look at this very carefully. What do you notice? It's not the same as what we saw up here. This time we have exactly the same thing on both sides. So think about it. No matter what we make x, it's like doing the same problem on both sides. Wouldn't it turn out the same every time we do the problem, no matter what we put in for x? Because I can't have this x equal one thing and this be something else. X can only equal one thing. So x could be negative 3, or I could try x being negative 15, or I could make x negative 85. Okay, it doesn't matter. No matter what I try for x, it's going to work. So I'll talk about what you write for this in just a moment. So let's finish it up. What we would do if we didn't notice that, we would go ahead and get all of our variables on one side. So I'm going to add an x here, add an x here, and that'll cancel out. That'll give us negative 15 equals negative 15. Well, this is a true statement. And whenever you have a true statement, you have infinitely many solutions. We could literally put anything in for x, and it would work because it's going to be the same problem done twice. Okay, so we'd write infinitely many solutions. Okay, and so that would be the answer. Again, you won't box this. You're the mathematician. You tell me what x can be. So you need to interpret your work properly and let me know what x could be. Okay, so there's our final answer. Now this is considered one solution. When it's one solution, you don't write down one solution. You literally write down what the one solution is. These are the only two we write words, okay? All right, and last one. Do you see it, guys? You're looking to simplify both sides, right? So we're going to distribute the -7. All right, so negative times a negative is positive. 7 and 7 went to 9. Now they are 49. Plus a negative times a positive is -14 equals -14 minus 2k. What I've noticed right now is that we have a -2k and a 49k. They're not similar. They're not going to end up canceling out, are they? So we've simplified that step 1. Step 2, put all the variables on one side of the equation that we are solving for. So I'm going to move this one. So we have 2k and 2k. So we have 51k minus 14 equals -14. So we know this isn't no solution or infinitely many solutions. K's are all on one side, so we're going to go ahead and just solve it. You know that you're going to only have one solution here. So add a 14 to both sides. Trying to get that k by itself. And over here, we have a -14 and a +14, so that cancels out. We can't just leave nothing because you can never just have a blank side. So this is when we will put our 0 in. Now we'll divide both sides by 51. So k equals 0 divided by 51. If you ever don't remember how to do that, you say 0 divided by 51. Go old school, go back to elementary, okay? 51 goes into 0, 0 times. 51 times 0 is 0. So the answer is 0. A 0 can be on the top of the fraction, but if it's on the bottom of the fraction, we have an error, okay? Which just means it can't be done, at least not now in your math career, okay? All right, guys, that's it for tonight.